finance, a la shmup. What is regression analysis? Regression analysis. No, it's not a therapy session in which your psychiatrist tries to figure out why you've gone back to using pacifiers. It's simply this: the process by which a series of different independent variables are compared to a dependent variable to see which might have the greatest effect on the value of the dependent variable. All right, well, okay, that's the theory of it anyway, but what about some practical examples? Well, what are these graphs and what do they tell us? Well, let's take Pete, the pizza joint guy. How does he know what's bringing in customers? Is it his new burrito pizza or the virtual skee ball machines he put in the back? Well, we can use some math here to find an equation, usually a linear one, linear regression, very fine mathematics sport, that best matches the pattern in the data. And then we can see how close the points are to that line, and that, will solve our burrito pizza skee ball conundrum and help Pete manage his business better. Well, the closer the data points are to the line, the more likely there's some kind of link between the independent and dependent variables. Well, it doesn't mean one variable causes another. It just means they're linked somehow. Like, what about the link between ice cream sales and drowning deaths? Well, that's a morbid connection, but see how close the data points are to that special line? So yeah, there's absolutely some meaningful link between ice cream sales and drowning deaths. Greater ice cream sales on a given day is always linked to more drowning deaths on that day. Why? What's the linking factor? Flavor of ice cream, the amount of sugar in the ice cream, too much in the ice cream, fat and crap and stuff, accessibility to public swimming pools? Well, clearly ice cream isn't some insidious killer drowning people who get in the water without waiting the requisite, hour. But there is a link between those two variables. Think about it. As it turns out, higher ice cream sales happen on hotter days. So heat or sunshine is the linking factor. More people go swimming on hotter days. When more people swim, well, there are going to be more drowning possibilities anyway. So ice cream sales and drowning deaths are linked, but ice cream sales don't cause drowning deaths. Got it? No causal link there. Similarly, check out how the points in this graph are not really close to the line at all. There's no link between your shoe size and your GPA. Unless you buy huge shoes, build a mini computer that fits in the extra space in your shoes and use that to help you, cheat. And don't do that, by the way. Always cite shmup. Anyway, back to Pete, the owner of Za's Pizza. Pete almost has more customers lately than he can handle. While the lightning is striking, Pete wants to find a way to, bottle it. The thing is, he's made two significant changes to his restaurant, and he's not sure which one is more responsible for the influx of people tossing money at him. Is it the virtual skee ball machines, or is it his new burrito pizza? Is there in fact any link at all? Well, it could be both that are responsible, but that's beyond Pete's skill and this course to determine. He can only compare one at a time to the increased revenue. So Pete picks different days and plots the number of burrito pizza orders against the total money made that day. Notice how the data points seem closely to follow an imaginary line there from the lower left to the upper right. In general, we can see that low burrito pizza order numbers are paired with lower daily revenues. Also, high burrito pizza orders are paired with higher daily revenues. High against high, low against low. Well, the closer the points are to that imaginary line, the more likely it is that the independent variable, in this case burrito pizza sales, is at least related in some meaningful way to the dependent variable, like it's dependent on sales, of total daily revenue. Onto our TI-84 there, or phone or computer or whatever you're using. First, we pop up our data into the list by pressing the stat button, then enter. We put in the X data in list 1 there, L1, and the Y data in list 2, L2. Now we press the second key and the mode key to get out of that menu. If we don't get out of that menu, well, we're just begging to screw the pooch here, so get out, get out. Now we bash stat, move over to the calc menu and choose option 4, which is linreg A, X plus B. All right, that syntax is shorthand for linear regression, yeah. On the menu, it brings up move down to calculator and then press enter. If your calc doesn't show the R squared and R values, well, you need to hit YouTube and search for how to turn on Stat Diagnostics TI-84. There's a bunch of important info in the results that we need to check out. Most importantly, for Pete's sake, is the value of R. The closer that R value is to 1 or -1, the closer the points are to best fit that possible line. Well, the closer the R value is to 1 for graphs with positive slopes or -1 for graphs with negative slope, the stronger the link between the independent and dependent variables there, right? That link is called a correlation, right? They correlate. It doesn't mean higher daily revenues are absolutely caused by burrito pizza lovers, but it does suggest they're somehow correlated, and that correlation is strong. Anyway, the A and B values that you see on the display happen to be the slope and y-intercept of the equation of the best possible line. Pete can use these to predict daily revenues if he knows the number of burrito pizza sales in a day, but that's a different video. Pete still needs to know if virtual skee-ball is so exciting that it might be more responsible for daily revenue jumps. He also plotted the number of times virtual skee-ball was played in a day versus those same daily revenue figures. Well, guess what? The points look like a cloud instead of having any obvious linear pattern. Well, if we pop that data into the calc and run the same linear regression process again, we get a very different R value. We can also just see that the points aren't that close to the line. That R value is not close to 1 at all. In fact, it's cozying up to 0 like it's a, frat boy, and 0 is, well, every girl within a 40-meter radius. When the R value is sniffing around 0 like that, well, it means there's some kind of very weak correlation between the independent and dependent variables. We can't stress enough that this isn't proof of any kind of cause, no matter how weak, between the two variables, just that some kind of correlation exists and that it's weak. Pete has some evidence that the increased daily revenue is almost all about the burrito pizza and only a tiny bit due to the virtual skee-ball crowd. But, this is a big but, Pete does not have proof. The R value just suggests that there's some kind of link between the two variables, not that a change in one variable causes a change in the other. Still, with that significant of a difference in R values, Pete is pretty safe in thinking burrito pizza is probably more important in driving higher revenues than virtual skee-ball. Pete used a regression analysis on the two different variables he thought might influence his bank account the most. Any decisions he makes going forward should probably be menu-focused as opposed to, attraction-focused. And still, he can't forget the virtual skee-ball entirely. It is probably a teeny bit responsible for the increased moolah. In Pete's case, the correlation between the variables was positive, which means that as burrito pizza sales or virtual skee-ball plays increase, well, so does daily revenue. And there are also negative correlations here as well, where as one variable increases, the other variable decreases. Case in point, Carlotta's Customs, right next to Pete's place. Carlotta's Customs takes broken down golf carts and, well, soups them up. They recently made 3 distinct changes to their builds and have noticed a huge decrease in the time it takes one of their carts to complete the 40-yard dash. Well, Carlotta wanted to figure out which change might have been the most responsible for the decreased times. Carlotta plotted 40-yard dash times versus the size of the rims, that's these things right here, their diameter, and got an R value of negative 0.179 when she ran a linear regression of the data. Then 40-yard dash times versus the cylinder diameter there, and got an R value of negative 0.628 when she ran a linear regression of that data. Then the 40-yard dash times versus the nitrous oxide concentration is what she ran, and she got an R value of negative 0.948 when she ran a linear regression of the data. Well, guess what? The simple fact here, all 3 plots have some kind of linear relationship. It does mean that there's some kind of correlation between each of these 3 variables: rim size, cylinder diameter, and nitrous oxide concentration. And the 40-yard dash time of the golf carts, which are mostly electric, but we won't get into technicals here. Since all the graphs have negative slopes and the correlation with nitrous oxide is the closest of the values to -1, the nitrous oxide concentration has the strongest correlation to decreased 40-yard dash times, like it's bad for speed. Reduce nitrous oxide in your golf cart. It's important to remember that Carlotta can't say that the nitrous oxide concentration is the direct cause of the faster times. All she knows is that there's a link or a correlation between them. Still, with further experimentation, Carlotta could establish a causal relationship. relationship. Carlotta explored the relationship between 3 different variables and their possible effect on the time to run the 40-yard dash using regression analysis. She determined all 3 variables had some kind of negative correlation to the times to run the course. As the nitrous concentration or the rim size or the cylinder diameter increased, well, the 40-yard dash times decreased. Clearly, the nitrous concentration had the strongest correlation. Carlotta should probably focus on that concentration for the greatest decrease in times. She knows she can't ignore the rim size, nor can she ignore the cylinder diameter, as they all contribute to overall golf cart 40-yard dash speed times, right? Regression analysis will never tell us which variable is the actual cause. It just kind of gives us hints along the way. It's best to make decisions informed by all the variables that are correlated to the dependent variable. And as Kelly Clarkson famously sang, miss independent variable, something like that. Miss independent variable.